Hello students, today we will study about single phase parallel circuit. In the previous lecture we have already studied about single phase series circuit. Here we are seeing that there is a three impedances connected in parallel with a voltage source supply V. Here is impedance, it is Z1, it is Z2 and it is Z3. Current flowing through the circuit I, and it is divided into three parts, that is I1, I2 and I3. This I current is the resultant of this I1, I2 and I3, sum of those three currents. So we have to calculate these currents and the phasor diagram of this circuit. For parallel circuit, we draw phasor diagram with respect to the current, and for series circuit, we draw with respect to the voltage. Here we draw the current phasor, and in series circuit, we draw the voltage phasor. So we are calculating the all the parameters, then we can draw the phasor diagram of this circuit. First of all, we have to calculate all the impedances. So for branch 1, there is impedance Z1, whose value I have already discussed is given by root under R1 square plus XL1 minus XC1 ka whole square. And current in this branch I1 is given by voltage V upon Z1, because in parallel circuit all the voltages drop across the branch is equal in the parallel circuit. So all the three branch voltages across this is V, here is V and V. So current I1 is equals to V upon impedance Z1. So this current I1 is given by, and the phase angle with the voltage phi 1 is equals to tan inverse XL1 minus XC1 upon R. So this current I1 will lead or lag with this voltage according to the value of magnitude of phi 1 is coming. That is, it is coming positive value or negative value. If it is positive value, phi 1 is positive, then it can be, it is lagging with the voltage V, because if here is the value, positive value you can take, then it comes over, is value is negative by polar division method. Then current I1 magnitude value is negative, then angle value is negative, then I1 is lagging with this voltage V. So Z1 value theta phi 1 is the positive value, so it comes to the negative. And if its value coming negative, that I1 will lead with this voltage V. Now for branch 2, so Z2 is given as this formula, and I2 is V upon Z2, and phi 2 is given as tan inverse XL1 X2 minus XC2. Similarly, Z3 and I3 can be calculated. So this current I is the resultant phasor sum of I1 plus I2 plus I3. So we can calculate this value. First of all, we have to draw the phasor diagram. Suppose that we are taking the reference voltage. Here is the reference voltage. And in series circuit, we take the reference as a current, and in parallel circuit, we take voltage as a reference. With respect to this, we can draw all the current value. So suppose that here I am supposing the I1 is lagging with the voltage V. Here I1 is lagging with voltage V, and I am supposing also that I2 is leading with the voltage V, and I3 is also leading with the voltage V. Depends on the value of this inductor and capacitor. Right? If XC is greater than XL, then current will lead. And if XL is greater than XC, then current will lag with the voltage. So I am assuming that I3, I2 is leading with V and I1 is lagging with V. First of all, I am taking the resultant of these two value I1 and I2. It is resultant of this value, and I suppose that it is I4. And this I4 and this resultant I3. I4 and I3 will come, resultant will be I. Here is that. First of all, I am taking the resultant of these two parameters considered as I4, and then I becomes I4 plus I3. These two resultant will be I. Right? Here we have assumed some wrong parameter, that is here I have assumed theta 1 and we have calculated phi 1 and phi 2 and phi 3, and here is theta 1, theta 2, theta 3. So don't confuse. This phi 1, phi 2 and phi 3 will be theta 1, theta 2 and theta 3. Sorry for that. Now we can calculate magnitude of this current I and this angle theta. So magnitude of this current will be the component of those two values, that is component along x-axis and component along y-axis. This current I resultant. So the I component, this resultant value across x component, x-axis is equal to sum of all these three currents across x-axis. That is, here I have written component of resultant current I along x-axis is equals to I cos theta, as you know. So this value is the sum of all three components of, so that is component of along three x-axis of all the three currents, that is sum. Now component of I across y-axis is the sum of all the three current component across y-axis. That is here written. I sin theta is the component of I across y-axis is equals to sum of all the three current component across y-axis. Hence, resultant will be given as these two components current sum. That is I cos theta ka whole square plus I sin theta ka whole square. That is, we can put the value here of both those components and it will be the magnitude of the current I. And angle theta is calculated as tan inverse I sin theta upon I cos theta, as you already know. So put the value of I sin theta, I cos theta. Now this value theta will compute the leading or lagging of the voltage. If theta is positive, listen carefully, if theta is positive, current will lead the applied voltage V. This theta will be positive, that is current I will lead with the voltage V. And if this theta will be negative, that is this current will lag with this voltage V. That is resultant should be here. On the basis of this, you can solve the numerical or practice the numerical. Thank you.